As a part of recapitulation, once again, I'm going to remind the main important points related to force and laws of motion. From laws from Newton laws of motion, we have learned Newton first law, second law, and third law, and inertia and types of inertia and force equation and force derivation F equal to ma, and the motion of the racket depends upon Newton third law, action equal to reaction. And today I'm going to remind the formulas force formula F equal to ma, and the SI units of force is Newton. From Newton's second law, we have already discussed about the new term that is momentum. What is momentum? The product of mass and velocity can be known as momentum. It is a mathematical definition, P equal to m into v. And the units, mass is measured kg and velocity meter by second. Kg meter by second is the unit of momentum. And as a part of Newton's third law, we have discussed one activity. The activity, two spherical masses m1 and m2 moving with initial velocities u1 and u2 in same straight line and same direction, both are collided together. After that, their velocity changes v1 and v2. Then the law of conservation of momentum gives the equation. What is the equation? m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. u1 u2 initial velocities and v1 v2 final velocities. Of course, after collision, both are stick together and moving, then v1 equal to v. Now the equation m1 u1 plus m2 u2 equal to v1 equal to v2 equal to v, then v into m1 plus m2. These conditions never forget. And problem number 1, I am going to explain. What is problem number 1? The velocity time graph of a ball of mass 4 kg moving along a straight line is given. So from graph, what is asking? How much of force does the table exerts on the ball to bring it to rest position? So here given terms, mass is 4 kg and the ball velocity gradually decreases. So from graph, initial velocity 2 meter by second and final velocity becomes 0 and time is 20 seconds. Now we are ready for the solution. Mass is 4 kg and initial velocity is 2. It decreases and becomes 0. So final velocity is 0. Time is 20 seconds. In this graph, x-axis indicates time reference and y-axis indicates velocity. The units are meter by second. So once again, what are the given terms? Mass 4 kg, initial velocity 2 meter by second and final velocity decreases and time is 20 seconds. Now these values I am going to substitute the acceleration a equal to v minus u by t. V is 0 and u is t and time is 20. Finally, what I am getting? Minus 2 by 20 equal to minus 1 by 10 meter by second square. And these acceleration value I am going to substitute the formula F equal to ma. Mass already given for acceleration, now you got minus 1 by 10. Finally, minus 4 by 10, that equal to minus 0.4 newtons. Now second problem number 2. An object of mass 100 kg accelerating uniformly from a velocity of 5 meter by second to 8 meter by second in 6 seconds. Calculate initial and final momentum of the object. Also find the magnitude of force which is applied on the object. So what are the given terms? Mass 100 kg and changing velocity from 5 meter by second to 8 meter by second. That means the final velocity is given, initial velocity is given. Time is 6 seconds. Is asking initial and final momentum and force. Now for solution. Once again the given terms mass 100 kg and initial velocity is 5 meter by second and final velocity 8 meter by second. Time is 6 seconds when object is moving from A to B. These are given terms. And momentum formula, you know that the product of mass and velocity. In that way, I am going to calculate momentum, initial momentum, mass into initial velocity. Here mass is 100 and the initial velocity is 5. 100 into 5 equal to 500 and the units of momentum you already know that kg meter by second. Now final momentum. What is the final momentum? Mass into final velocity. So 100 into final velocity 8. So 800, the units of momentum kg meter by second. So this is the final momentum. Above one is initial, other one is final momentum. Now I am going to calculate magnitude of force. F equal to ma. A means V minus U by T. So once again I am going to calculate magnitude of force F equal to ma. A means V minus U by T. So substitute the values. Mass 100 kg and final velocity 8 and initial velocity 5 and time is 6. So 100 into 8 minus 5 by 6. So 100 into 3 by 6. 100 into 1 by 2. And finally what I am getting? 50 newtons. This is the magnitude of force applied on the object. And problem number 3. Observe the problem number 3. An object of mass 1 kg traveling in a straight line with a velocity of 10 meter by second collides with and sticks to a stationary wooden block of mass 5 kg. Then they both move off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate the velocity of combined object. So here two objects are there. First object 1 kg, second object 5 kg. Both are collided together and move together. So in this way, what is asking? Calculate total momentum just before impact and after impact. Also calculate the combined velocity. And ready for the solution. Mass 1 kg, it is moving with initial velocity 10 meter by second. It collides wooden block 5 kg which is in rest position. Stationary means rest position. So its initial velocity is 0. After collision, both are moving together. So both are getting common velocity v. Now the equation m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. After collision, both are moving with combined velocity. So that v1 equal to v2 equal to v. If you can substitute, you are getting v into m1 plus m2. What is the equation? m1 u1 plus m2 u2 equal to v into m1 plus m2. Now I am going to substitute the values. Given values. m1 1 kg, u1 10 meter by second, m2 5 kg, u2 0. V into V we are going to calculate common velocity after collision. M1 1 kg, M2 5 kg, total 10 equal to 6V, V equal to 10 by 6, that equal to 5 by 3 meter by second. So in this equation, M1 U1 plus M2 U2, this is before collision, equal to V into M1 plus M2 after collision. Now total momentum before collision we are going to calculate. What we have discussed, the total momentum before collision m1 u1 plus m2 u2. Substitute the values 1 into u1 10 plus m2 means 5 into 0 equal to 10 kg meter by second. Next, total momentum after collision v into m1 plus m2. Already I explained. V means recently we got 5 by 3 into 1 plus 5. So 5 by 3 into 6. 3 ones are 3 twos are. And 10 kg meter by second. And both total momentum before collision is equal to total momentum after collision. Now problem number 4. What is the problem number 4? How much momentum will a dumbbell of mass 10 kg transfer to the floor if it falls from a height of 0.8 meters? So it is freely falling body. The problem by itself indicates a freely falling body. So that acceleration due to gravity g equal to 10 meter by second square. From this problem, what is asking? Momentum. Now, as a part of solution for this problem, once again the given term, so mass 10 kg. So, is asking momentum. Momentum formula P equal to mv. M you know that 10 kg. V we don't know. Before calculating V, a dumbbell falls from a height of 0.8 meters. It is a free fall. So that free fall, you know the conditions, u equal to 0, a equal to plus g. And g value you can take 10 meter by second square. Before calculating V, I have taken equation of motion number 3. What is equation of motion number 3? V square minus u square equal to 2as. So v square minus u means 0 square equal to 2. A means what? Plus g. S means h. So v square equal to 2gh. So v square equal to 2, g value 10, h value 0.8. So v square equal to 16 and v equal to 4 meter by second. We are getting v equal to 4 meter by second. The value I am going to substitute. Momentum formula P equal to mv. M already 10 and v recent we got 4. So 10 into 4 equal to 40 and the units are kg meter by second. Thank you.